Okay, g'day students, welcome to our lesson on time zones. So today we want to define Greenwich Mean Time, the International Dateline, and the UTC, or Coordinated Universal Time. We'll understand the link between longitude and time. We'll look at the number of degrees of longitude for a time difference of 1 hour. We'll solve problems with time zones. We'll do that with GMT, the International Dateline, and UTC. We'll look at two places on the surface of the Earth and calculate time differences, and we'll just do some other general calculations. So let's look at some definitions. Now, time zones are calculated in relation to that of Greenwich in London. So here's London here, and remember that's our prime meridian, or our Greenwich meridian, and GMT is the predecessor to the Universal Time Coordinated, which is what we use now. Now the International Dateline, which is here, it's 180 degrees east or west of the prime meridian. So remember, Earth is a sphere, so if we chop it in half, half of it is at 0 degrees, and the other half is going to be at 180 degrees. So just chop it in half like an orange, for example, and the line down that is going to be 0 and 180 degrees. So that's 180 degrees east or 180 degrees west of the prime meridian. So if I were to jump from here to here, I would go back 1 day, just one step over that line. Now, if we can see here, we've got 360 degrees in a circle, and 360 degrees divided by 24 hours in a day. So 360 degrees divided by 24 hours, that's going to give me 15 degrees per hour. So that means each time the Earth rotates 15 degrees, an hour has gone by. Now if you see these lines here, you can see that they are 30 degrees. So that's actually saying 2 hours, isn't it? So each of those lines are 2 hours apart. If I were to look up here, you can see that Australia is in our +10, sorry, Brisbane is +10. There's more to Australia than just Brisbane apparently, or Bundaberg. And Perth over here is in our -8. So there's 3 time zones there. Now there's 1 hour time difference for every 15 degrees. Although in reality, look at China. It's a huge country, and it's just got one single time zone, so it's dependent upon the government of the country as well. You can also see Alaska doing some funky things as well. Now we can also just divide that 15 degrees, and we'll notice that 1 degree is going to be the same as about 4 minutes time difference as well. So 60 minutes per hour divided by 15 degrees will get you 4 minutes. Now, let's have a look at this one. Australia's what? 2,511 miles wide. Canada is 3,402 miles wide, and China 2,193 miles wide, according to the World Atlas of 2015. So Australia's got 3 time zones. Canada has 5 time zones. Oops, Canada does not include Alaska. So, oops, so there's Canada. And what China? And this is what I mentioned. So you can see that, first of all, Canada's further apart from the equator. Look at the difference in miles. So it's still got, 900 miles extra, but it's got an extra 2 time zones. So Canada's further from the equator than Australia, so that means the meridians of longitude are closer together. Now, China's government has just said, well, the whole country will be in 1 time zone. So that's the reason for the difference to Australia. Let's have a look at this one. On the 28th of February 2016, Jill turned 21. 2 days later, her older brother turned 21. How is this possible if they were born 10 minutes apart? Well, it would be possible if Jill and Bill crossed the ship as across the international date line. So Bill was born on the 1st of March on the west side of the line, and the boat had crossed to the east side by the time Jill was born. So she was born on the 28th of February. Now 2016 is a leap year, so their birthdays are 2 days apart. That's just a bit of fun. Okay, now Bundaberg is what? GMT plus 10. So we lie here. And Auckland is in GMT plus 12. So they lie here. So if it's 9 o'clock in Bundaberg, what time is it in Auckland? Well, all you need to do is calculate the time difference. And you just say, well, 12 GMT plus 12 minus GMT plus 10 equals 2. So we've got a time difference of 2 hours. So we know that Auckland is east of Bundaberg, so it's got to be ahead of Bundaberg. So it's just going to be adding on 2 hours to say 11 o'clock in Auckland at the same time. Now, if we have Bundaberg GMT plus 10, so Bundaberg's in our GMT plus 10. Now, Los Angeles is in GMT minus 7. If it's 9 a.m. in Bundaberg, what time is it in Los Angeles? Well, we've got to calculate the time difference. So we go back to the prime meridian, and then we go back, and so we go back 10 and we go back another 7. So we know that there are 17 hours difference between Los Angeles and Bundaberg. So the time in LA is 9 a.m. minus 7 a.m. So one way you could determine that is just say, well, we've got 12 a.m. We're going to minus that 17 and then we're going to minus that 12. And that's like saying 12 take 8 hours. So it's 4 p.m. on the previous day. The way I tend to work it out, folks, is if it's 9 a.m., I'm going to say, well, 9 take 9 is that's going to be what? Midnight. So 12 a.m. And then I've still got to minus the rest of the 8 hours, so haven't I? So 17 is broken up into that 9 and that 8. So then I can just say 12 a.m. minus 8 hours, and that will get me to, well, 1600. So, well, 1600, 24 take 8 is 1600, and that's like saying 4 p.m. And that's on the previous day because we are heading west. Okay, what should be the time difference between Bundaberg, 25 degrees south, 155 degrees east, and Shanghai, 35 north and 120 degrees east? Well, we need to look at our east-west coordinates. And what did we say? We said, well, it's 15 degrees per hour rotation. So we just do that minus 155, take 120, well, that's 35 degrees. And then we can say 35 divided by 15, and that should be 2 and a bit. What have we got here? 35 times 4, what's that? 4 minutes per degree. And actually, I'd advise you to stick with this one here. Just work out from 15 degrees per hour, and then we just say, well, 35 degrees divided by that equals 2 and a bit. So in this case, it's about 2 1/3. So that should be around 2 hours and 20 minutes. Now, daylight saving time is it generally occurs in summertime. So it's when places closer to the poles or away from the equator experience longer day lengths during the summer. Now, it doesn't make much sense for places close to the equator have daylight savings because that there's not much difference between winter and summer daylight hours. So remember, the equator is more exposed to the sun. It's going to have less variation in its daylight hours. So Queensland, WA and Northern Territory don't have much of a difference in their summer and winter day lengths, so we don't use daylight savings times. But for southern states such as Tassie, Victoria, South Australia, New South Wales, they will. So what do we have? We've got, first of all, 3 time zones for Australia. So Western Australia is UTC plus 8. Now, Australian Central Time, well, that's like plus 9.5, isn't it? 9:30. So for South Australia, And for the rest of the eastern seaboard of Australia during summer, we're 10 hours ahead of GMT. However, Sydney and Victoria, for example, they will go to Australian Eastern Daylight Time during the summer months. And now those summer months go from the first Sunday of October to the first Sunday in April. And they put their clocks forward at the start and they put their clocks back an hour at the end of daylight savings time. If we look at Dallas, this is a little bit of a backward question from before. So here's Dallas down here, that's hard to see. If it's 9 a.m. in Dallas, determine the time in Brisbane, which is UTC plus 10. So what we want to do is we just want to consider the time difference. So in this case, I've got the time zones on the map for you. So we can just calculate the difference by doing the plus. So it's 6 hours behind plus 6 hours ahead. That's going to be a time difference of 16 hours. Now, if I say 9 plus 16, I'm going to get 25. Now, there's no such thing as 25 o'clock. 2400 is midnight, isn't it? Now, 1 hour after midnight is 1 a.m. the next day. We've done a lot today. We've defined Greenwich Mean Time, Universal Time Clock, and the International Dateline. We've talked about the link between longitude and time, particularly what there's 15 degrees for every hour. We've looked at time zones in Australia and other nations and done a little bit of maths on those. When you're happy with that, please work on your mastery questions.